Welcome to the
Welcome to the Creating IPsec
lesson.
Virtual Private
Click
Networks lesson. After completing this lesson, you will be able to achieve these objectives. Understand what IPsec Virtual Private Networks, VPNs, are and why they are used. Understand how FortiGate IPsec VPNs work. Configure IPsec VPNs using FortiGate devices. IPsec is a suite of industry-standard protocols that is used to create secure connections between devices located on different, and often geographically distant, networks. These secure connections are known as Virtual Private Networks, or VPNs. Depending on the configuration used, IPsec can provide some or all of the following features: data authentication to verify the source of the data, data integrity to prevent data tampering, data confidentiality to encrypt the traffic, anti-replay protection to prevent replay attacks. These features are extremely important because, in most implementations, the VPN traffic travels through non-secure networks like the Internet. One important advantage that IPsec VPNs have over other VPN solutions is that they don't require the intervention of service providers. All that you need to establish a secure VPN tunnel is IP reachability between the two ends of the connection. IPsec can be used to create two types of VPNs: remote access VPNs and site-to-site VPNs. Click each VPN to learn more. In both types of VPNs, after the connection is established, the devices in one network can reach the devices in the other network. When connected through a VPN, devices in different networks become part of the same logical network. Regardless of the IPsec VPN type used, the IKE protocol is used to create the tunnels dynamically. FortiGate supports the two available versions of IKE, IKE version 1 and IKE version 2. While IKE version 2 includes several security improvements over IKE version 1, the latter is still widely used in many VPN deployments. When using IKE version 1, the IPsec VPN process goes through two stages: Phase 1 and Phase 2. In Phase 1, the two peer devices authenticate with each other and establish a secure channel that they will use to negotiate the security parameters of Phase 2. This first channel acts as the control plane of the VPN connection. The peers can be configured with several combinations or proposals. Each proposal consists of several security parameters. For a successful Phase 1, the following parameters must match in at least one of the proposals on each peer device: IKE mode, main or aggressive, authentication, encryption algorithm, hashing algorithm, Diffie-Hellman group. Other parameters don't need to match because they can be negotiated. Phase 2 can start only after Phase 1 completes successfully. In Phase 2, both peer devices determine which traffic must be sent over the VPN and how it will be authenticated and encrypted. In this phase, a subtunnel of the parent Phase 1 tunnel is created. This subtunnel acts as the data plane. Like Phase 1, the peers can be configured with several Phase 2 proposals. For a successful Phase 2, the following parameters must match in at least one proposal on both peers: encryption algorithm, hashing algorithm, Diffie-Hellman group, only if PFS is used, which is highly recommended. Other parameters don't have to match since they can be negotiated. The traffic that is to be protected must be indicated by listing the local and remote subnets that will communicate through the tunnel. In a remote access VPN, both subnets are configured on the server side. In a site-to-site VPN, the subnets on each peer must mirror each other. IKE version 2 was designed with several improvements over IKE version 1, both in security and performance. It is the recommended protocol for new IPsec VPN implementations, unless the available hardware does not support it. Although it shares many similarities with its predecessor, IKE version 2 does not include two phases and is not backward compatible with IKE version 1. Some of the benefits of using IKE version 2 over IKE version 1 include the use of fewer messages reduces the latency and the bandwidth used during the negotiation of the tunnels. The use of sequence numbers and acknowledgements in its messages. Support of EAP adds more flexibility, scalability, and interoperability during the authentication process. Support of PPK, post-quantum pre-shared keys. Support of asymmetric authentication allows the peers to use different authentication methods. Support of stronger security algorithms. For example, FortiGate supports PRF-SHA for hashing and AES-GCM for encryption, both with several bit links available. Better resilience against DOS attacks. FortiGate firewalls support ESP protocol for the authentication and encryption of VPN traffic. ESP provides data encryption, data integrity, and data origin authentication, but it does not provide identity authentication. However, identity authentication is provided by IKE during Phase 1 negotiation. The following table shows some of the most well-known encryption and hashing algorithms supported by ESP in FortiGate. Click on each value to see more details. The following are some general best practices that can help you to avoid unexpected issues when configuring VPNs with FortiGate. Click each tile to learn more. FortiGate provides an intuitive wizard to help you easily configure IPsec VPNs. The wizard includes several templates with security settings that are appropriate for the most common scenarios. The security settings include various proposals combining different levels of AES for encryption and SHA-2 for hashing. If for legal or compliance reasons you are required to use specific security parameters, you can create a custom tunnel. This will allow you to select the specific settings that meet your needs. Another option is to convert a tunnel created with a template into a custom tunnel so you can edit all its settings. The FortiGate GUI also makes it very easy for you to monitor VPN tunnels. Not only can you check whether a tunnel status is up or down, details about traffic volume, and even the status of both Phase 1 and Phase 2 are also shown. This can be very helpful while troubleshooting. For example, if only the Phase 2 tunnel is not working, it means that the peer devices were able to create the Phase 1 tunnel. Knowing this means that you can discard lack of connectivity as the reason for the failure. You can proceed to double-check that the parameters were configured correctly on both devices and that they include at least one matching proposal. Now, let's watch a senior Fortinet instructor demonstrate the following tasks.
And I'm here to show you how to configure and then test a site-to-site IPsec VPN. Task 1. Create the IPsec VPN using the VPN wizard. FortiGate includes an easy-to-follow wizard that you can use to create all supported VPN types. For this demo, I will use the available template for site-to-site VPN with FortiGate firewalls on both sides of the connection. Let's start by connecting to the FortiGate GUI of both devices and log in as the admin. Note that with some important exceptions I will mention later, the configuration on both devices is exactly the same since most of their parameters must match. On both FortiGate devices, click VPN, VPN Wizard. I'll start with the local FortiGate. By default, the site-to-site option is already selected. I will name each tunnel according to the firewall location HQ to branch and the other branch to HQ. This name is used for several objects that are created automatically for us, so it is important to choose something easy to recognize, especially if you plan to have several VPN tunnels ending on the same device. I will click Begin to enter the configuration details. Given our topology, I can leave the first two options in their default settings. In the IP FQDN field, I need to type the external IP address of the peer device, that is, the other FortiGate. For the remote site subnets that can access VPN field, type the internal subnets of the pure FortiGate. This is a good example of why having the topology diagram at hand is very useful. For a successful connection between the networks involved, the local and remote subnets on each firewall must be a mirror of the other. Click Next. On the pre-shared key field, type the key that will be used for mutual authentication on both devices. This value must match on both firewalls. In a production scenario, ensure you choose a strong key. In my case, I will use something simple like password. Click Next. In the outgoing interface that binds to tunnel field, I will select one of the external ports on each FortiGate. For the local interface, in my scenario, I must select the only internal port for each FortiGate. The local subnets that can access VPN field will be automatically populated to include the subnet associated with the selected port. However, note that you can add more ports and more subnets if needed by clicking the plus sign. In our topology, we have only one subnet behind each firewall, so I can click Next. Review the summary displayed and notice the names of the different objects that will be created. Click Submit. The GUI will take you to the VPN tunnels page where you can review and edit the settings if needed. Notice how the tunnel was successfully created and that it is currently with the status of inactive. VPN tunnels will become active and change their statuses to up when traffic is sent from a device on one of the local subnets to the other. Now I will follow the same process on the second FortiGate. Before testing if our configuration works, let's examine the objects created by the VPN wizard. I will do this on one of the firewalls only, since the other one is basically the same. Let's start by clicking Networks and then Interfaces. Expand port 1 and notice the tunnel interface named HQ to branch. Now click Static Routes and notice there are two new entries, both with the same destination. Hover your mouse over the destination column and click the geared wheel icon on the left to add another column to this view. Click Distance and then click Apply. Notice the first one is the route to the remote subnet that will be used when forwarding the VPN traffic since it has a lower distance. The second entry is a black hole route with a higher distance whose purpose is to prevent packets from being sent outside the VPN tunnel when the tunnel is down. Now let's examine the two firewall policies created. To do that, click Policy and Objects, and then Firewall Policy. Expand the entries that refer to the HQ to branch tunnel interface to see the policy details. In our example, these policies are a mirror of each other that allow traffic to and from the subnets configured for the tunnel. However, there may be scenarios where these policies may need different settings. Next, click Addresses. Type HQ in the search bar and then press Enter to display only the objects we are interested in. Luckily, we used a good naming convention. Notice the two addresses for the local subnet and remote subnet respectively. You can always edit these objects later if the requirements demand it. For example, you may need to add more subnets that will use the VPN. Task 2. Test the site-to-site IPsec VPN. Now that we have both FortiGate firewalls configured, let's test that the VPN connection works as expected. I will connect to a computer located in the local subnet behind the remote FortiGate, and I will open a CLI session. For a quick test, let's ping the IP address of a computer on the other side. In my case, that will be 10.0.2.10, and press Enter. As you can see, the ping is successful. You may notice that the first ping takes a little longer. This can occur when the VPN tunnel is not already up, and it takes a little time to negotiate everything before allowing the traffic through. Let's return to the FortiGate GUI, and under VPN tunnels, we now can see the tunnel status change to up, and everything is working. To wrap this section up, in this demo, we configured two FortiGate firewalls for a site-to-site IPsec VPN using the wizard provided. We then tested connectivity between the two internal subnets in our topology. This concludes this demo. I hope you enjoyed it.
Let's put these concepts into practice by completing the following lab simulation. You have completed this lesson. You are now able to understand what IPsec virtual private networks, VPNs, are and why they are used. Understand how FortiGate IPsec VPNs work. Configure IPsec VPNs using FortiGate devices.